Your cell phone is mainly made of plastics and metals. It's easy to appreciate the inventive process by which those elements are made to add up to something so useful and entertaining. But there's another story we don't hear about as much. How did we get our raw ingredients in the first place from the chaotic tangle of materials that is nature? The answer is a group of clever hacks known as separation techniques. They work by taking advantage of the fundamental properties of things to disentangle them from each other. Simple separation techniques apply to many physical scenarios, like separating cream from milk, extracting water from soil, or even sifting out flecks of gold from river sand. But not all mixtures are so easy to unravel. In some of those cases, we can exploit the differences between physical properties within a mixture, like particle size, density, or boiling point, to extract what's required. Take petroleum, a mixture of different types of hydrocarbons. Some of these are valuable as fuels, and others make good raw materials for generating electric power. To separate them, experts rely on one important feature. Different hydrocarbons boil at different temperatures. During the boiling process, each type vaporizes at a precise point, then gets separately funneled into a container and collected as a liquid as it cools. Separation techniques also take us to the sea. In some drought-stricken countries, the ocean is the only available water source. But of course, humans can't drink salt water. One way to get around this problem is to remove salt from seawater with reverse osmosis, a process that separates water's ingredients by size. A membrane with pores bigger than water particles but smaller than salt particles only lets fresh water pass through, transforming what was once undrinkable into a lifesaver. Meanwhile, in the medical world, blood tests are a vital tool for evaluating a person's health. But doctors typically can't examine blood samples until they've separated the solid blood cells from the liquid plasma they're dissolved in. To do that, a powerful rotational force is exerted on the test tube, causing heavier substances with higher density, like blood cells, to move away from the rotational axis. Meanwhile, lighter substances with lower density, like plasma, move to its center. The tube's contents divide clearly, and the blood cells and liquid plasma can be tested independently. But sometimes, unlike oil, seawater, and blood, the parts of mixtures that we want to separate share the same physical properties. In these cases, the only way to isolate ingredients is by chemical separation, a complex process that relies on unique interactions between components within a mixture and another material. One of these methods is chromatography, a tool forensic scientists use to examine crime scenes. They dissolve gathered evidence in a gas and can monitor and analyze the ingredients as they separate and move at varying speeds due to their unique chemical properties. That information then tells scientists precisely what was present at the scene, often helping to identify the culprit. Separation techniques are not just about industry, infrastructure, medicine, and justice. One of the most technically ambitious projects in human history is a separation technique aimed at answering the fundamental question: what is the universe made of? By accelerating particles to extremely high speeds and smashing them into each other, we can break them into their constituent parts, ever so briefly. And if we succeed at that, what's next? Is there a most elementary particle? And if so, what's it made of?